So, hallo zusammen und willkommen zur heutigen Jungle Academy. Gleich gibt es einen Vortrag über die ARC 42 vom Richard. Der wird euch zwar nochmal einen kurzen Überblick geben, glaube ich, über das vorherige, weil das ist ein aufbauender Vortrag. Das heißt, der Anfang der ARC 42 wurde schon mal besprochen. Gibt es auch eine Aufzeichnung von, sogar auf YouTube, die könnt ihr euch anschauen, wenn euch jetzt seine kleinen Recap, wenn euch das nicht langt, quasi da nochmal der Hinweis. Ansonsten, Richard, übergebe ich gerne an dich und viel Spaß.
Vielen Dank, Leo. And now I'm going to switch to English to keep everyone involved, hopefully everyone involved. And as Leonard already mentioned, I'm going to talk about the ARC 42 today. It's the second part of the series we wanted to do. Christian Kupsch and I started together making the first part of the series. And as you all know, probably that we are partially a little bit busy. I've taken the second part on my own, but he does not yet know. Hopefully he will do the third part on his own then. So, and then to not waste any time, I'm gonna skip up to the agenda. So what we're gonna do today, or what I'm gonna talk about, is first a little bit introduction to what's the ARC 42 overall, what is its intention, which chapters do exist overall, giving a short introduction to each chapter, and then we're going to go into the real topic for today, and these are those 4 chapters you can see right here. So it's chapter 4, the solution strategy, it's chapter 5, the building block view, chapter 6, the runtime view, and chapter 7, the deployment view. And at the end, I'm going to make a small conclusion and give you some more information and some useful resources, links, and if I'm not forgetting it, I will also mention a few examples. Well, then, why am I doing this presentation? I want to provide an informative and engaging session that educates you and me, on the other hand, because I can had some time to get into much deeper into the topics. And as mentioned, it's those 4 chapters today. So one very important thing why I'm doing this is the knowledge sharing. I want to give you the valuable information, some insights about the chapters and how you should maybe think about it and what it gives you. And also that it provides the opportunity to disseminate some knowledge that you need to for the understanding of some architectural viewpoints. And also why this is very important in a system and the software architecture of the system. I'm going to highlighting the relevance because the presentation emphasizes the whole chapters 4, 5, 6, and 7 to get it into a broader context for the software architecture. And I'm trying to make it more understandable for you why it is that important. Also, I want to explain you or enhance your understandings why it is so important to write those. Not only why are they relevant, you want you to understand why they are relevant. And also, I want to give you a few best practices to show you how it can be done and what actually helps you, what does not help you. And I want to encourage you to adopt it. Use the ARC 42, use it in your project, project, and keep pushing it because it helps you all the time. And also, I want to get up you all that you get a discussion, and also the collaboration is one main point why I'm doing this here, to get you more informed about the software architecture at all, and especially about the ARC 42 template. So, as mentioned, there's a series, the part 1 of the series is available, which you can find here. The link is also available somewhere in the Confluence of our Jungle Academy. So, what is the ARC 42? It's a pretty big question for some, maybe, that hasn't had the chance to watch part 1. So the Arc42 documentation is a framework for documenting and communicating system and software architectures. It gives us a structured approach to capture and present the essential parts of a system, and more importantly, in a concise and understandable manner. The documentation follows a modular format. It has various chapters. They try to cover different aspects of the architecture. They have specific views, especially the 4 chapters today are mostly about how you can look at the system from different viewpoints to eliminate a few blind spots that we usually get from time to time. So, but to give you an overview of all chapters, I've just written them down. I'm going to tell you a little bit about them. Sorry, that was the wrong button. The introduction and goals, which we handled in series 1, in part 1. This chapter sets the context for the architecture documentation and outlines the goals and objectives of the system. It usually also includes a stakeholder list and the most important quality goals. Chapter 2 is about the architectural constraints, the organizational constraints, and the third one that I'm just right now don't remember, but there is a third one, the legal ones for sure. So where we can prescribe all of these because of every decision has to pay onto that. The third chapter is context and scope. This chapter defines the system boundaries. We identify some additional stakeholders that are outside of the actual project, and we describe the system's interactions with the environment. Usually in the Arc42, you're having 2 contexts, the business context and the technical context. As the name suggests, they are for a little bit different groups to address. So the business context is more for the business people. They decide on more the business values, and the technical ones more for the technical people. So the first chapter we're going to look in today is the solution strategy. And this chapter focuses on defining the approach for designing and implementing the system. It also includes the prioritizing of the requirements. We need to analyze some challenges within that. And we select the technologies and patterns we will use overall the system. Chapter 5 is the building block view. This chapter focuses on the decomposition of the system and into its major components, which responsibilities those components have, which relationships they have, and which interfaces are used by them. So it's about the major components. This is very important. Otherwise, you would end up in a documentation that no one will read and is just way too big to maintain. Because documentation always has a sense. It should help us. It should not stop us. When we're now coming to chapter 6, it's the runtime view. This one captures the dynamic behavior of the system. So it's just a different viewpoint on how the system works. So usually you're using the pretty common UML sequence diagrams, or maybe also some different diagrams. On chapter 7, which is the last one for today, we're going to talk about the deployment view, which is, I think you can guess, the view on how the system is deployed, how's the actual real environment of the system. So we're going to talk a little bit about how the components can be distributed, about different nodes, how's the infrastructure, how's the network. This goes deep into which hardware it actually runs, so the physical hardware. Or maybe if you think about a Kubernetes cluster, it's also about the virtual machines. If we are not really relying on the physical hardware, if we are getting this out to someone else when we use infrastructure from others, that's like Azure. Chapter 8 is about the cross-cutting concepts. It addresses the common concerns that affect multiple architectural views, such as security, performance, scalability, and within there we provide guidelines and patterns how to handle them. For one pretty common example would be the authentication, how this would be handled, because this needs to be, you need to be aware of this when you look into the system on many views. Chapter 9, the design decisions. There we focus on documenting why we made a decision. Most commonly, an architecture decision record is used. There are several ideas of how an architectural decision record should be written exist. Honestly, most of them are absolutely sufficient. So chapter 11, the lovely one, risks and technical depths. Within this chapter, we need to write down the potential risks we see, the technical depths we made when we are aware of them. And also, if we're able to, we should directly address strategies or suggest them on how we can manage them or maybe even mitigating them. Chapter 12, the glossary. To get a common understanding with the stakeholders or with all project members, it's most of the time very helpful to define a few wordings you're usually using when talking about a project. So overall, the ARC42 documentation promotes a pragmatic and lightweight approach to architecture documentation. It focuses on the essential aspects while leaving enough room to adapt and customize it to the specific needs of the system, and therefore using the context of the system itself. It serves absolutely important right now as a valuable resource for architect development teams and stakeholders. This is one very helpful thing to talk about software, to get knowledge from the stakeholders and also to move knowledge to the stakeholders about why decisions are made this way, and to most obviously, I think it's the visualization that helps talking about stuff. So now I'm going to give you a short and brief overview of the chapters for today, which they are really addressing. So, sorry, give me a second. So chapter 4, the solution strategy, plays a pivotal role in the system and software architecture as it lays out of the approach and the plan for designing and implementing the system. So within here, we are focusing on making informed decisions to address the architectural changes we will have when we are designing our system to meet the goals and requirements of the system. So what's important there, we have to prioritize our requirements. We have to analyze them, then prioritize them. When I'm talking about requirements, what do I actually mean? It's such requirements. So we need performance, we need security, we need maintainability, and we need to define what this actually means. Another thing is to analyze and resolve challenges. Within this chapter, we identify these challenges that maybe could come up during the development process and try to directly offer strategy to tackle those risks, to tackle those bottlenecks, and we're gonna decide on which trade-offs should be done. For example, if you need high performance and on the other hand, high security or a high data correctness, these are stuff that usually is not so easy to get both. So you have to make a trade-off. So what we also do within this chapter is we select appropriate technologies and patterns. We select them based on our analysis and prioritization before. So if we, for example, only need to display the current value of some sensor or something like that, then maybe the correctness is not absolutely needed, but it is required that it's very fast at the end user. So you can decide on which patterns help you to fulfill that, because you know why you would do it. one very important thing overall is to document those design decisions. So there are two things. You have to document your decision, which happens in chapter 9 in your architectural tricks, and you describe why you decided for what and why you did not choose another thing, for example. And the other thing is you have to document the actual way how it is done. So see chapter 9 more as a history of why decisions are made, and the current standing decision as at least for this topic here in this chapter. Another thing would be to promote iterative and incremental development. So if the documentation is as the code a living thing, you have to adapt it. If you're making, if you're getting new information, you get more knowledge, you maybe have to adapt things. And then you have the possibility to adapt your documentation to give every new developer or even old developers that went with old, I mean developers that are in the project for a long time, can have a place where it can look stuff up, because you usually cannot remember everything. So building block view. Sorry, I need a second. The building block view is crucial in the system and software architecture. It's really crucial. It provides a high-level overview of how the system structure and its major components. We focus within this chapter to decompose the system into building blocks, which usually represent cohesive units of functionality or responsibility. So why is it that important to have this view? We could enable modular design just by identifying and defining the building blocks. We can easily manage it to maybe get even better design and more capsulation. We will highlight the relationships between the We'll highlight relationships and dependencies. So with the building block view, we have those components, we connect them, and then we can see how they will probably interact with each other. So it's helpful to identify potential failures or bottlenecks. Then we're going to come to the overview of the runtime view. The runtime view focuses more or less on the dynamic behavior. If you think about the chapter 5, which is the building block view, you have just some, a little bit stuff written down, and this does that, but you actually don't know which happens at which time. What happens at which time, sorry. So with this, where you can ensure a correct system behavior, because if you illustrate it, and you can see it, it usually helps you, and you're able to communicate the expected behavior to the developers, and also you're able to communicate it to the stakeholders of what will be implemented. So this can help to eliminate a few hours of trying stuff out and then delivering maybe another a wrong solution, because it was just not what the stakeholder expected. This also supports us by troubleshooting and debugging, because if we know how the stuff should work and we see it does not work like that, we have directly a point where we can get in to find out why it does not behave like that. So then jumping up to chapter 7, the last one for today, the last one in this overview. We're going to get a little bit more into it directly following. So the deployment view focuses on the physical deployment of the system. It includes the hardware infrastructure, the networks, and the distribution of the components across different nodes. So why is it important for us? So it helps us for the infrastructure planning. We can design the necessary infrastructure to support our system. We can identify the hardware requirements, the network configurations, and the allocation of common components to specific nodes. For example, if we're having a cache, this thing should maybe not run on, making fun of an E386. So maybe we need a little bit better hardware on that. So also it can help us to get better with scalability and performance, because if we know the topology of the deployment, then we can find out where maybe it's a bottleneck or maybe it's another problem. The system resilience and availability is also a point where this chapter will help us, because the deployment view enables us architects to design a robust and fault-tolerant system. We can identify single points of failure, we can plan better, we can get redundancy into it, and also add failover mechanisms that are maybe not even part of the core system, but can be done by the deployment. Just think of if your pod dies within Kubernetes just restarts it. So this is very helpful. So, and with this, we can then ensure high availability and reliability. When we now comprehensively address these aspects in these chapters, we can really establish a very solid foundation for our architecture and ensure the system's correct behavior, and also support our critical configurations such as modularity, performance, maintainability, and also for sure the deployment considerations. So now we're going to jump into chapter 4 a little bit more in detail, which is the solution strategy. So I know I'm going to repeat myself now from time to time, but I'm doing this on purpose. I'm aware that I'm repeating myself, but I think that it will help you to get the stuff into your head. So the solution strategy focuses on defining the approach and the strategy for designing and implementing the system. It highlights the importance, also identifies and prioritizes the quality requirements. We also analyze the architectural challenges to make informed decisions, which is very important. Always make informed decisions. The chapter provides also guidelines for selecting appropriate technologies and some patterns on how we will solve problems. We will also promote an iterative and incremental development, because our documentation can live as our code does. And if we follow the instruction and the strategies we outline in this chapter, we can ensure that the system is designed in a way that meets our quality goals and requirements, which is what the reason why we are actually doing all this. So when we're now getting a little bit more into prioritizing the requirements, it is a crucial aspect of the solution strategy in Arc42. As when you remember, without those requirements, you're gonna have trouble to decide what is the best for your system. So some key points about the requirement include the understanding of the quality requirements. With those, we encompass various aspects such as performance, security, usability, scalability, maintainability, and more. It's very important to gain a clear understanding of those specific requirements. So then, when we understand the quality requirements, we can analyze and rank those requirements. So when we analyze and rank them based on their importance and also on the impact of onto the system, we can then make better decisions, which is more important than another. So this also involves then assessing the criticality, the business value, and the stakeholder needs associated with each requirement. So as you can see, this is all stuff that should be at least started before the first line of code. So also we have to consider the trade-offs. When we get into prioritizing, we have to make trade-offs between conflicting and requirements. For example, prioritizing performance may impact other factors such as cost or development time. It's important to evaluate and balance these trade-offs based on the project constraints and priorities. I'm going to run out of water, so at some time. So what is also helping us, it's helping us to collaborate with the stakeholders. When we prioritize the requirements, we can do this only with the collaboration of the stakeholders, also including the business representatives, in the best case, some users, some architects, and some developers. And when we involve the stakeholders, we can understand what they actually need. And then we can actually quite well align some priorities and ensure that the prioritization reflects the goals of the system, the requirements, and the stakeholders. As usual, as this is a documentation template, we have then to document the stuff. Why do we document it? To being able to read it up afterwards, and also more importantly, to get into the communication. I think you're with me when I say, if you have something in front of you where you can talk about, it's much easier to get into some directions and get forward. It's always a little bit harder to start on the green field when having nothing. So then we're gonna go into the next important thing in this chapter. It's about analyzing and resolving those challenges that are coming up when you then have to get a strategy on how to implement and solve all those requirements and quality goals. So the key points are identifying the architectural challenges. So architectural challenges can arise due to various factors such as technical constraints, scalability requirements, security concerns, performance bottlenecks, or maybe just integration complexities. And because of this, it's very important to proactively identify these challenges and understand their potential impact on the system. Because if you're getting it to, you have the knowledge too late, you're maybe totally in development and you've wasted time and therefore the money of your customer, which is something we should always avoid if we're able. Another thing, the risk analysis and mitigation. Once we have the challenges identified, we need to analyze the associated risks and the potential consequences. This also involves assessing the likelihood of occurrence. So the potential impact of the system. And then we need to develop mitigation strategies to minimize, or in best case, eliminate these risks. This sounds like a perfect world, but we all know it's all gonna be most of the time to mitigate strategies to minimize the risks. Totally getting risks out is just not really it's not, I believe it's not possible to eliminate risks to 100%. Prove me wrong, I'm open to that. So also decision-making and trade-offs. When we resolve those challenges, we require informed decision-making. And with this, the trade-offs. So then we have to document them. We need to evaluate the different options that we have. So will our microservices, for example, communicate always per API calls, or will they be decoupled with some messaging? So both has advantages and disadvantages, and we need to know why we made this or that decision. In complex scenarios, prototyping or developing proof of concepts can help in validating design decisions and resolving challenges. Prototypes allow for early identification of potential issues, such as performance bottlenecks or integration challenges. They provide a means to iteratively refine the design and mitigate risks before full-scale development. For example, when you're for example, implementing server-side events, you're going to somehow end up with the problem that you're not being able to handle authentication by some default. And actually the currently existing out-of-the-box solutions are everything but not secure. So there's a point where you should probably write a proof of concept or a simple prototype to validate the decision you have made and then get up with it. So another thing, monitoring and continuous improvement. And when we resolve a challenge, we will not always be in this process. This is always an ongoing process throughout the whole system's life cycle. So we should monitor the system performance so we can get a feedback and then analyze the real world usage to identify a new challenge or maybe get areas for improvement. So we additionally have the iterative approach to ensure that our system keeps his quality goals and his requirements. So, and when we now proactively analyze and resolve all those challenges, we can, as an architect, mitigate risks, and we can make informed decisions, and we can develop robust solutions. We are also able to address technical complexities, ensure the system stability, and optimize the overall design and the implementation of the system. Also, every decision should be documented. So next thing I'm going to talk about is how to select appropriate technologies and patterns, because there's no day where not another JavaScript framework is coming out. So you should be aware what you do and why you do it and why you've chosen that. So to actually do this in a good way, you should understand the system requirements before selecting the technology and patterns, because then you can decide based on information and then consider all these factors I've already talked about, such as performance, scalability, security, usability, and maintainability. So you should evaluate the available technologies. As an architect, you need to look which frameworks and libraries can fulfill the system requirements. This involves researching and analyzing various options, considering all those factors such as compatibility, community support, scalability, performance, licensing, the expected time the framework or the product you or the technology you decide on could exist. So maybe the framework will just run out of maintenance in a few months or years. That's one of the few things you should always think about. You should align with your architecture principles, so that the chosen technologies and patterns should align with the overall architecture principles and design goals. They should fit in very well within the architectural style and support our desired qualities. Risk assessment is one of the most important things overall, not only in this in this chapter. I'm sorry, haven't slept that much this night. So we have to select the technologies and pattern and be aware that they often carry inherent risks. So we should address the risks, we should assess them, and also directly deliver solutions or prototypes or proof of concepts to help the actually implementing developers to not get into these problems. One very, very important thing where I'm always talking about, I don't know which, I don't remember a week within my professional working time where I did not talk about the balance between innovation and stability. So we always are in between. We want to be innovative. We always want to use new stuff because it's most of the time very helpful. But on the other hand, we need a stable system. So we always have to be aware when it makes sense to choose which technology. Maybe you can in a project try out one thing, but then you should be ensure that the other stuff around just works as expected, and you're not really going to have any problems with that. So it's always based on the customers, the project, the requirements. So you're never going to be able to say, do it like that. That want to work in every project. And again, document technology decisions, most importantly, because we need to have this documented to be able to talk to the stakeholders and developers in a quite good way. So, but always be aware, think of also of the Agile principles. It should help us, it should not stop us. Yeah, more words on the document design decisions. Why do we do this, or why should we do it? With a good documentation, we get clarity and traceability. It doesn't matter which architectural choice we made. We can help the stakeholders to understand the reasoning behind these decisions, and we can ensure that we understand the system design. We can also, when we describe our document decision, the context and the constraints around. So because our decisions are always influenced by such factors, such as the business goals, technical constraints, the budget, the regulatory requirements. And when we document these for all design decisions, the stakeholders can understand why we do it that way. And we know it in a later point of time why we did it that way, because maybe some constraints changed over time. Just think of what was before the GDPR, in German DSGVO, was implemented. We acted on some stuff a little bit different. For everyone who knows what really was behind, yeah, we actually should have been done it before like that, even after German law. So also the impact analysis. When we make decisions and document them, and use such kind of a framework as the ARC42, we can analyze the impact of our decisions in a quite good way. And as usual, the communication collaboration is very, it helps us to do the communication and collaboration. Because if you have something visual before you, especially with stakeholders, nothing against stakeholders, but they're just not developers who need to get something they can get with us. Also, the evolution and maintenance. When we document this, we can also adapt it, and we know when we adapt it and why. So with this, we can promote iterative and incremental development. So we get agility and adaptability. We get early and continuous delivery, because if we are gonna ship small fragments of our products, we get feedback quite fast. And then we can get into some kind of feedback-driven development, because the customer can play around with the system and then give us more information. When we do it step by step, we can get into some risk mitigation, as we can try to, and also get some continuous improvement, because we're always getting feedback and getting better. Because even if we try to find all challenges, the reality says usually one or two things will be missed out. And also it helps us to increase the collaboration transparency of what actually happens within the system. So then we're now up to chapter 5, the building block view. The building block view mostly focuses on the decomposition of the system in its major components and their relationships, interfaces, and also their responsibilities. So we're having a high-level view of the system structure and can promote some modular design principles. When we identify and define the building blocks, we can organize the system functionality into some manageable current modules. So this view gives us a highlight of the relationships between the dependencies, and with this, it enables us to create an effective system integration and coordination. So a little bit more explanation on that. It's a view that focuses on the decomposition into major projects, and everything I just said. We're using components, relationships, interface, contracts, deployment units, and it still helps us to get more modularity, understand the system structure, and support integrations. So what are the key components? Sorry, confused. Sorry, as with the components. So my additional notes were not fitting my slide. The components are the fundamental elements in the building block view. They represent a cohesive unit of a functionality or responsibility. A component can be a module, a class, a service, or any other logical grouping of functionality. So the component encapsulates a specific set of responsibilities and provides a well-defined interface. Important. So the relationships depict the associations and dependencies between the components in the building block view, so that we can highlight the relationships and how the components would interact and collaborate with each other. The interfaces define the contracts or the protocols through which the components actually communicate. So the contracts, I don't think I have to get into deeper into that. So we define a contract that we know how we have to talk to each other. We will also see deployment units that represent the physical arts or entities in which components are deployed and executed. Sorry. Also the composition. So we can see how are those components arranged together, how do they have a relationship to each other, and so on. A second, please. So, and when we are creating the building block view, we can also pretty easily ensure that we have the encapsulation ensured as a principle, because we are creating such blocks and components, and therefore we try to get the information hiding done and the separation of concerns. So it involves also the bundling of the data and functionality into a component, and then we only expose necessary interfaces to other components. So in the abstraction, it focuses on capturing the essential characteristics and ignoring unnecessary details. So we're going to get an overview of how all the system works, not especially we want to know how one single method does some stuff, but it depends. So what are the benefits when we use the building block view? So we get modularity and separation of concerns. The building block view with this promotes the modularity just by decomposing the system into cohesive components. We can understand the system structure in a much better way because a clear and structured representation of the system as architecture exists. Therefore, architects, developers, and stakeholders get a high-level overview of the structure, and they can understand how these components work together. And this also helps us to make fact-based decision-making, which is the thing we should always do. It will also help us to integrate the system and coordinate the actual modules, how they should interact with each other. And then we can pretty well control what happens within them and how they interact with it. And when we have the building block view, we can easily get into discussions about the scalability and the flexibility of the system because we have something to look at. And it's also probably easier, at least out of my view, to encourage reusability and the interoperability because you directly see, oh, there's a component that actually does exactly the same thing, or we only have to make a small change to get reusability. And it is also supporting for the maintainability and evolution because if you know which stuff exists, you can actually create components, add components in a much nicer way that they fit in to the system. Yeah, last but not least, architectural consistency and documentation. So we can ensure that the architecture is consistent if we see that is consistent, and therefore we have to document it. Now, maybe I'm going to skip the deployment view today because we're a little bit far in time. But now we're going to get into chapter 6, the runtime view. So the runtime view is a perspective in system and software architecture that focuses on capturing the dynamic behavior of a system during its execution or runtime. It provides insight into how components interact, how messages flow, and also the sequence of actions that occur that the full system can fulfill its functionality. Yeah, just what I said. But additionally, it also helps us to validate the system behavior. Afterwards, we can realize use cases in a simple way, or not realize really, you can visualize them, and then when you have the visualization, you can realize them in a much more simple way. Maybe some of you have seen the sequence diagram of the class ship. This is one thing that's pretty nice and shows what a system could do. Or not what it could do, what it should do. Sorry for that. And also, if we're having performance issue, we can look at those sequence diagrams and know what happens or what should happen. And if not that happens, what we would expect, it can help us with troubleshooting problems. Yeah. And when we're looking at the runtime view, we can also see where the concurrency problems or possible problems. We can say where we can really easily see where we need state management, how it actually works. And one also very important thing is the system monitoring and the maintenance for it. Because when we have a good system monitoring, we can can get easier into the maintenance point, because we then pretty much and easily know what our system does, how it does, and which problems occurs. For example, every day at 8, there's the problem that you're having some timeouts because just too many users are logging in or something like that. Then you maybe need some strategy to scale up in front of, or have a better scaling up on demand. So in summary, capturing the runtime behavior is significant in a system and software architecture, as it allows us the validation of the behavior, the realization of the use cases, some performance information, and troubleshooting. So what are some key elements and concepts within this chapter? It's the dynamic behavior. So the runtime views emphasize the system's behavior and execution during runtime. So we can capture interactions, the exchanges of data, the control flow between the components, and then we can illustrate how a system actually responds to various stimuli. A little bit looking into the future. If you're creating quality goals and a quality tree, you usually end up with some quality scenarios which are started with some stimuli, and therefore they have to react on those. One very important thing is the sequence diagram. It's a UML standard. It's an industry standard. It's pretty well defined. And I think everyone should at least be able to understand and read them. So as usual, communication and collaboration. I cannot say it often enough, same as documentation. So we highlight the components, and then we can communicate those tasks and the existing information much, much more easily. Sorry, and then we also have some dynamic aspects, again, such as concurrency, or also the event-driven behavior and state changes, which we can very nicely visualize with it and describe within this chapter. So this provides us means to validate the system behavior and so on. And we can then manage the concurrency and state as we know how we wanted it to work. And then we can check if it actually meets our performance requirements and our functions, our function reliability in all of those scenarios. So as we now have 10 minutes left, I'm gonna go into the deployment view, but gonna leave just one or few things out. And in the next part of the series, we're gonna start with chapter 6 again and get some more information on that. Chapter 7, I'm sorry. So this focuses on the deployment view, which is an essential perspective for us, because we need to know how our system will actually run and where it will run, how it will be distributed about hardware and over multiple or different environments maybe. So when we're looking at getting a small overview, so we're having a physical deployment. That is actually the thing that gets deployed. So just to get you this into your head, this can consist of a little bit hardware or virtual resources. It just shows how the system's components are allocated. Sorry, previous. So what does it help us actually? It helps us to plan the infrastructure, to analyze the scalability and availability, and assess risks. If we see that we're only having, for example, one gateway, and this gateway is just running on an i386, then we know that's probably not gonna work, and we are directly see what we should change. Now, a short introduction to the key elements and concepts. So a component within the deployment view represents the software artifacts or modules that make the system up overall. So we see which component is deployed to which hardware or virtual resource, or to which node maybe. So the node represents the physical or virtual machine, a server or container. So with thinking of Kubernetes, it's usually a pod. And then we know where it actually is deployed. So within this view, we're going to show the communication paths, which stuff that communicates with which parts and which protocols are actually used. We need them to maybe identify potential bottlenecks and ensure that the communication can actually happen. So, for example, Kubernetes again, if the used service account from one pod is not allowed to access another pod, then we're going to have a problem. And this is just a pretty obvious one. So we will see which dependencies we do have. For example, if we need external services, just like a database as a service or a keyboard as a service or what else you can think of, this will be documented here. We will also be documenting down here the environments where our system will be deployed. Usually you're having more than one. I would say at least you're having a development and a production system for a middle-sized project. Small projects may be different. So, and also we can directly see what are the scalability and availability considerations for this thing. Because we directly see is scalability available, and if not, it will be documented why it is not available, and so on. This will help us. One last thing, at least for now, security and access control. So this does actually not mean how you authenticate your user and so on, but you will describe how the authentication mechanism overall works, also which firewalls need to be opened, which encryptions will be used within those communications. So when we then understand these key elements and the concepts, we are able to know how the system is deployed without actually logging into several servers and trying to figure out how it should work and then getting into debugging. So the benefits of using this, we can get better infrastructure planning, we get better scalability and performance optimization. We can get into a high availability and fault tolerance if we're also using our documentation and try to gain the knowledge we need to fulfill this stuff. We talked about the security considerations you have to be aware of. As usual, collaboration, communication, essential part. It's the main reason of documenting software and its architecture. We can easily find out if our deployments are consistent. If we're having multiple, we can check against the actual deployed system against our documentation. And it will probably help us if something is not working, we then know how it should be. Last 5 minutes, I'm gonna skip the conclusion for a bit. The recap overall is just the same as I just told you before. If you want to get a short recap, just look the video again. And then I wanted to show or share a few links and resources. The arc42.org, where the template is actually coming from. Arc42 in Practice is a book by Gernot Starke. It's, I think, for everyone who works with the Arc42, a must-read, or at least for those that write it. Another very nice book, I think, is The Software Architecture for Developers by Simon Brown. Probably some of you already know this, or many of them. And what I really, really like as a book is The Software Architecture in Practice by Len Bass, Paul Clements, and Rick Kessman. And as you all know, there are, I don't know, hundreds, thousands of software architecture books out there. So if you're having a really good book or a really good YouTube video, I would be very interested if you would send them down to me. And if you want to have examples for all of this, it's not that easy. In the previous part, we showed examples, the doc test example that was created to help anyone getting started with the Arc42. Today, I decided against it out of the reason as it does just, out of my view, only captures this one case. So when you're then talking about an enterprise application, it will look totally different. And therefore, I would maybe just guide you into a wrong direction. But if you're ever going to start to write an Arc42 and you don't know where the one or other thing should be placed or how you can get into these informations, don't be afraid. good things will happen soon, and we will tell you from the software architecture channel how you can do this in a quite easy and representable way that you can just get your information and then create a good documentation, make good decisions, and then create awesome software, which is actually the only thing I really like in my life. I really like when working, I want to create good software. I'm also having another few things I like in my life, don't get me wrong. So, thank you for listening. I hope I could give you some insights on of all that and ensure or increase your interest into those topics.
Yes, thank you for the presentation. I hope you can hear me because I have some trouble with my audio signal. And please excuse the German moderation in the beginning. I didn't think of this presentation as being in English. And thanks again for this presentation. Luckily, I'm in Richard's team and we are using the ARC42 in our project, and I can highly recommend it. And if you want to start to use it, just call Richard and he's gonna help you. And if there are any questions afterwards, just reach out to him and then, he will answer that questions. So, and there aren't any questions in the chat. So I think everyone is satisfied for today. And yes. Then I wish you all a good weekend, and we will see us next week in the channel.